Dear students, I am Rama Brahmam. I have been mentoring students for more than 3 decades. Without knowing the concepts, applying formulas leads to wrong results. Rote memorization without understanding concepts is unhelpful. Let us solve these problems using conceptual approach. It clear up many conceptions. Let us look at these problems. Here, 2 microfarad capacitor is charged to 10 volts. So its capacitance is 2 microfarads. It is charged to 10 volts. And another one, 3 microfarad capacitor charged to 20 volts. So after charging, they are disconnected from their sources. So once they are charged, charge still remains bound on the plates of the capacitor. So what is the charge stored on the first capacitor is 20 microcoulombs. Charge stored on second capacitor is 20 into 3, 60 microcoulombs. Now here it is 20 microcoulombs. So another one is having 60 microcoulombs charge. Now and after disconnecting, again connected in a closed series in a loop. Which of the statements is false? That is question. This one is a isolated loop, right? It is not connected to any external battery. It is at higher potential. It is at lower potential. Charge flows. So since they are connected in a loop, charge flows from higher potential to lower potential. It is at higher potential. Some charge delta Q flows from higher potential to lower potential. So now the charge on it becomes 60 minus delta microcoulombs. So that charge get deposited here. So here, which is at lower potential, it gains a charge, right? At equilibrium stage, they will have a same potential. Potential you can calculate, that is nothing but 20 plus delta Q by capacitance, 2 microfarad is equal to 60 minus delta Q by microfarads are there, micro get cancelled. 60 plus 3 delta Q equal to 120 minus 2 delta. Here it is 60 is equal to 5 delta Q. Delta Q becomes 5 microcoulombs. So that means initial charge on second capacitor is 60 microcoulombs. At final means when they reach common potential, charge on second capacitor 60 minus 12, 48 microcoulombs. Similarly, charge on first capacitor is 20 plus 12. 32 microcoulombs. So both are correct. Now third. So energy lost by 3 microfarad capacitor. The energy is equal to initial energy half C2, right? V1 square, V2 square. C2 will be 3 microfarad. V2 will be, that is at 20 volts. That is 600 microjoules. Final will be half C2 V square. C2 is 3 microfarads. Common potential, so right. What is common potential here? It is nothing but delta Q is how much we got? 12. Delta Q is 12. This common potential becomes 20 plus 12 by 2. That is 16 volts. 16 square. That is 3 into 128. How much here? 484 microjoules. Loss will be 600 minus 484. Here it is 2. So 126 microjoules is the loss. So third option is wrong. So potential difference is 16 volts, right? This problem also can be done in other way to find common potential. So when they reach common potential, initially charge is conserved. Q1 plus Q2 is equal to Q1 dash plus Q2 dash. C1 V1 plus C2 V2 will be C1 plus C2 of V. So V will be C1 20 plus 60 by 2 plus 3. 120 80 by 5, 16 volts. So the common potential. Generally, where is the possibility of misconception since they are connected in series? You try to solve this by taking common effective capacitance, this becomes wrong. This, when it is connected to external source, it is okay. So it's not connected to external source. Only two capacitors, finally they connected without external source, charge flows from higher to lower. So, so another question here is, this is also good question for you. A parallel plate air capacitor has area A1 and A2. So this is one plate. Here you have another plate. Right. So its area is A1. Its area is A2. So here it is, let us say A2, he told A1 is more than A2. Effective capacitance. General formula is effective capacitance means we write A epsilon by A epsilon naught by D. That is when, so both plates are of same area. Now they are of different area. So then how do we calculate effective capacitance? So here electric field lines in the common area we have to consider. So here you get a uniform field lines. So at other than common area, you get field lines like this, which are not uniform, right? So the common area definitely becomes which is having least area. So that least area will be 8. So effective capacitance becomes epsilon naught A2 by D, fourth option. So in the next consecutive videos also, I'll discuss some more interesting questions.